was net change. Here's the net change, right? From my interval of integration, net change. Doesn't look any different, right? Fundamental theorem of calculus, basically. Which, by one of its definitions, not only the area under the curve to the x-axis, but net change, net rate of change, net. Well, if this is true, and greater minds than ours have proven it to be true, one of man's greatest discoveries, then this must be true. Because this is just, well, I guess, algebra. I was going to say arithmetic, but I guess this is just algebra. This one makes sense, right? That I could find actually one of the end pieces if I know what the change is, or I'm able to get the net change. Here's where I started, here was the net change, this has got to be where I ended. Something like that. Okay, so that's it. That's our net change. And accumulated because, you know, we're starting and then we're changing and then where do we end up? So this means we can find the other endpoint if we already know or are given f of a and the net rate of change between a. It even works if b is less than a, because I know this to be true. So even if, you know, they gave me bigger number to smaller number, I can flip it and just do the opposite, because I know that's true. So it works, you know, whether you're going from small to big or big to small. Cool? Okay. That's it. Let's do some examples. I know that is it. I got the answers on here, but we won't. Here we go. There's some. Okay. A function is known to be increasing. That might be good to know. At a rate. Oh, rate. That means derivative. Well, there is the derivative. Prime of x. 3x plus sine x. It's also known that at x equals 4, the function has a value of 15. Find the value of the function at x equals 7, and then again at x equals 2. And you might want to use a calculator to compute this. Okay, so we can do f of 6, or f of 7 first. We want to find f of 7. Pretty much asking where did I end up. So I know that's going to be where did I start. It's known that f of 4. Well, I know f of 4. I know the xy value here. So if I figure out what 4, we know x is 4. And it's increasing. So if I add the net rate of change, 3x plus sine x, dx, hey, if I go from 4 to 7, I should be able to get it. Because I know what f of 4 is. That was 15. And then I could probably pick this up from my calculator. Kind of running into each other. And let's see what you guys get. There could really be one this easy, I think, because you have to know how to set it up.
64.79.
64.79. I got some decimal line.
63.092.
That's what I get. So
This calculated probably in
let's see, so you got 4 to 7, 3x plus 7x.
it's probably in. And you've been rating.
Oh, yes. Never change that.
Yeah.
Sorry. Yeah,
Cool.
getting something different, yeah.
Let me make sure I'm.
It's because of the math thing.
Oh,
It's
yes.
like keep on changing stuff.
I usually tell people never lend their calculator to anybody. Be selfish with you because they may be hitting. Yeah, there we go. Yeah. So everybody getting 63.092. Make sure your calculator's in rating. And they didn't really give me any units of measure, so I'll just write down 63.092. And I know that because that's where, if I did this and subtracted this over, I would have the fundamental theorem of calculus. The integral from 4 to 7 would equal this minus this. Pretty easy. Okay, what about, they also said at, when x is 2. So f of 2. So if you want to, let's see, f of 2, and I've got f of 4. What should I do?
Make it negative.
I could make it negative. So basically, let me just do this real quick. I could do f of 4 plus, that would have to be integral 4 to 2. Right, because if we subtracted that, that would have been that, I would have had this. Now, let me do it this way. Two of 3x plus sin x dx. Yeah, that's how I would get that. Plug in the top number minus plug in the bottom. So when I do this now, which is what I just had up there, add that over to that equal. Plus what's up there? 3x plus. Yeah, I could just do, well, f of 4, that hasn't changed. It's still 15. And I could just do this. I could flip the intervals and just say it's going to be 3x plus 7. Just be careful, you know, how it's set up. Just set it up correctly. And this is why it could very easily be a question on the AP exam, because it's all based on setup. So let's see what we get this time.
Minus 3.037.
Got to vote for minus 3.327?
Yeah.
Or 237?
Yeah.
Oh, was that right? I got a negative. What does that mean?
There's some more.
Must mean I was going backwards.
Oh.
Yeah. Yeah, that's all it means. It just means I'm going backwards. Yeah. So according to the problem, that's okay. Oh, and that might lead us into the number 2 example. And I'll just do that one, and then we'll save number 3 when everybody gets back. So if you want to start. So we'll look at number 2. I know I got the answer there, but let's see how. Any questions on this? Just be careful, you know, which number to which number, how you're setting it up. And if you wanna set it up this way, fundamental theorem of calculus, hey, this, I know last year they came back to me and they said there were some of these in there. So, if a lot of the country missed them, and they might be on there. It's a very easy thing, but I guess people are missing it. Now I got a tank of water. A tank of water is leaking at a rate modeled by that derivative. Rate derivative. There we go. Where V is measured in gallons and T is measured in days. Oh, now I've got some units of measure since the leak started. No water is being added to the tank, so it's just leaking. And the tank held 24,000 gallons when time was equal to 2. So at day 2. So that means T of 2 was 24,000. How much water is in the tank 4 days after the leak started?
Wait, mister, if you don't put units on the actual AP test, can you get a blank take home?
Yes. If they provide the units. If they provide the units, make sure you put your answer in those units. Yeah. I know that sucks. So anyway, probably it's gonna, here we'll go ahead and set it up. It's probably, let's see, from 2 to 4, right? The integral, the change is gonna be from 2 to 4 of this thing, negative 25 pi. Over the square root of t dt will equal, okay, so this is obviously the derivative, so I'll get v of something, v of 4 minus v of 2. So in this case I'm doing 4 minus 2. I'm always doing top minus 1, unless you made it negative. And so let's see, it looks like I've got v of t, so why don't I isolate this? Do it this way. How much water's left? So we can do v of 2 plus this. And I'm gonna have some, I keep saying 2, it's 25 pi. 25 pi. Hey, water's leaking. Shouldn't that be, hey, where I started minus? If it's leaking, it's getting smaller. I'm thinking I should. But it's already included it. Because in the wording, it said it is leaking at this rate. If they said it was changing at this rate, I would have to remember, wait a minute, if it's leaking out, it's probably getting small. But this one says it's leaking, so they've already included the negative. So basically, I can pull that negative out. So V of 2 was what, 24,000? And then I can pull that negative out, 2 to 4, 25 pi, over square root of t. Should give me V of 4. Which is the volume, not velocity. I should probably do capital V. Volume, not velocity. Volume, not velocity. We want to know. And let's see what you guys do. Hey, you could even make it easier. Not only pull the negative out, that's a constant, 25 pi. And then I got the integral from 2 to 4. 1 over t to If you wanted to. But you get the same. What do we get? 23,907? 23,907 with a little bit extra. That's what I got. So that's gonna equal 23,907. And they love their 3 decimal places, so I'll say 98. Did you get 9848? Okay. So they're okay if you put 984. I'm kind of old school. 9848 means they'll take either one. And that's gallons. I believe. Yeah, gallons. Because they gave me the units. I'll make sure my answer has the units. That's net changes accumulation. That's it. I got nothing else except another example that's gonna be the same thing. Just be careful how you set it up. That's the tricky part. If there is a tricky part. And that's all. And tomorrow we'll just work on this.